Good morning, students. In this video, I am going to explain examples for histogram equalization. So, okay, here consider here one 3-bit image. So, that is L is equal to 8. That means number of gray levels in the image is 8 for 3-bit image. Now image size is 64 by 64. So here total number of pixels in this image is nothing but 64 into 64 gives 4096, that is m into n or small n. So here small n number of pixels in the image is 4096. Now here to apply the histogram equalization on this particular image to get the enhanced image, right? We should establish one table here like this. So actually this table is given. Here we directly take this table. Okay. Now here first we observe the first column. What is that? RK. RK is gray levels. RK gray levels are there where k is 0 to L minus 1. Here L is 8. Now here k value is nothing but 0 to 7. So now R0, R1, R2, R3, R4, R5, R6, R7 gray levels are there for this image, and those are nothing but R0 is 0, R1 is 1 and so on, R7 is 7. So, okay, now coming to the second column that represents total number of pixels. What is that? Number of pixels with the gray level RK. NK is nothing but number of pixels with the gray level RK. That means N0 is nothing but number of pixels with the gray level R0. Here R0, 0. Now here what is this? 790 pixels are there with the 0 intensity. Okay, in the image. And then again consider this one. What is this? 1023. What is the 1023? 1023 pixels are there with the intensity 1. Similarly, 850 pixels are there with the intensity 2. In the same way, 81 pixels are there with the intensity 7. Okay. In this way, you should, what is that? Take the RK, NK values from the image. Okay. So now here, after calculating this NK, immediately find out PR of RK. PR of RK is the probability of the what is that? RK, that is nothing but normalized value of this NK. That is, do the here or take the formula NK by Mn or N. So here Nk by Mn or Nk by N means here N is 4096 and then take here 790 and divide that one with the 4096, then you can get the PR of R0. So 790 by 4096 is 0.19, 1023 by 4096 is 0.25, 850 by 4096 is 0.21. So in this way we just calculate and then noted down all these values like this. So 81 by 4096 is 0.02. Okay. Now after finishing this table, right? Okay. So right, we should calculate SK values with respect to this RK. Okay, right? SK values. Okay. So here these are the actual image gray level values, right? So here this is nothing but how many pixels are there with the RK, and these are nothing but normalized values of NK or probabilities of RK. So if you add all these values here, if you add all these values, then you can get the total number of pixels in the image, that is 4096. So in the same way, if you add all these here values, probability values for RK, So you should get the 1 value. So right. So the sum, if you add all this, you can get the value 1. Okay. So check it once. Now here, uh, for the image, right? So if you observe the histogram, right? So if you want to establish the histogram for this image, so right? So you should draw the histogram in two ways. One is based on the NK versus RK. That is the first method. The second method is nothing but based on the PR of RK versus RK. Right? So here observe the diagram, histogram or graph between PR of RK versus RK. PR of RK versus RK. It is also called as probability density function. It is the input image histogram or probability density function of the input image. Okay. Now, so on x-axis take RK, 0, 1, 2, 3, 4, 5, 6, 7 values are there. And y-axis take PR of RK. So, here PR of RK means 0 to 1 range. So, here 0, take the 1 as the maximum value and then you just take a scale, uniform scale like 0, 0.2, 0.4, 0.6, 0.8, 1 like that. Otherwise, if you observe the table here, the minimum is here almost 0 and maximum is here 0.25. That means the maximum value is here 0.25. So, here mark 0.25 and then here consider the scale like that. Okay, so split the scale. So, like 0.05, 0.1, 0.15, 0.2, 0.25. It's okay. And now note the, and then here mark all the values here. Okay, for the corresponding RK values. For 0th intensity, what is the PR of RK? 0.19. Okay, 0.19. So, for 0, 0.19. For 1, what is the value here? 0.25. Right? For 3, what is the value? For 2, 0.21. For 3, 0.16. Like that. So, here different values of PR of RK. Right? With respect to the RK, you just indicate in this graph. So, now here draw the discrete lines like this. Okay, this is the discrete graph. Okay, discrete nature graph. Okay, now here if you observe this histogram or PDF to the particular image, so here you can easily say that here higher intensities, that means the pixels with the higher intensities are less when compared with the pixels with the lower intensities. So, maybe the image looks like a, what is that? Dull image, dark image. Okay, to distribute these particular, what is that, lines, discrete lines or histogram, so uniformly it is observe, it is like this. Okay, but we need like this. Okay, that means here, right? So, to change this non-uniform distribution of the histogram to the uniform distribution histogram, right? So, we should apply histogram equalization. Okay, histogram equalization transformation is nothing but here Sk is equal to L minus 1 summation PR of Rj. So, or L minus 1 summation Nj by N. So, here this is the Rk. So, that is related to the, what is that, input image, and Sk is nothing but that is related to the output image or enhanced image. And of course, from the point operation, you know that. So, Sk is equal to T of Rk, transformation of Rk. Here that the transformation operation is nothing but histogram equalization. That histogram equalization operation is L minus 1 summation Nj by N. Okay, so here take this formula to find out the Sk values from the Rk values. Okay, right. Now here, so see this after finishing this. So remember here the definition or the formula for the Sk, and then so look here. So after establishing this histogram, right, based on what is the two methods, right? So one is the Nk versus Rk, other method is PR of Rk versus Rk. So here I have what is that shown, what is that, this one PR of Rk versus Rk. You just draw the graph for Nk versus Rk also. Okay, right, it's okay. Now coming to this one, calculation. To find out the Sk values from the Rk, so use the histogram equalization transformation operation, that is Sk is equal to L minus 1 summation PR of Rj or Nj by N. So okay, here observe this formula. So and then you can easily identify that S0 is nothing but L minus 1 summation J0 to 0, K0 here, PR of Rj. That means J0 to 0 means J0. That means PR of R0. What is the S0 value? L minus 1 into PR of R0. That means here PR of R0 0.19 into 7. Into 7 into 0.19 is S0. What is the S1 here? L minus 1 summation J0 to 1 PR of Rj. That means L minus 1 into PR of R0 plus PR of R1. Am I correct? So now S1 is nothing but L minus 1 is here 7 into PR of R1 plus PR of R0. That means 0.25 plus 0.19 into 7. That is the here S1. What is the S2? L minus 1 summation J0 to 2 PR of R2. That means, so 7 into PR of R0 plus PR of R1 plus PR of R2. That means here, what is the observation here? This is nothing but cumulative addition of these PR of Rk values, right? So to get the PR of, what is that? To get the S0, take this one 0.19 and multiply this one with the 7. To get the S1, right, add these two, multiply with the 7. To get the S2, add these 3, multiply with that with the 7. And similarly, to get like S6, what will we do? What is that? Add all these and multiply with that one with the 7. And then for S7, add all those PR of Rk values from this to this. That means obviously that is 1, that is into that is multiplied by the, what is that, L minus 1, that is 7 here. So now obviously S7 is 7 only. Okay, it's okay. In that way you should take the calculation and take the equation and expand and write the equation like that. Okay, and then do the multiplication and then get the answers like this. So S0 is 7 into 0.19 gives 1.33. S1 is 7 into 0.19 plus 0.25 gives the 3.08. S2 is 7 into whole one and then 0.19 plus 0.25 plus 0.21. Okay, gives the 4.55. Now similarly do that one as do the calculation and find S3, S4, S5, S6, S7 as this. Okay, right. After completing all these values and then take the another table, right. In the first column take the Rk values as 0 to 7. In the second column take the Sk values, right. So as for 0th value, what is the here? Sk 1.33, right? For 1 intensity 3.08, for 2 intensity 4.55, for 3 intensity 5.67. Similarly, right? So just here note down all the values, okay, S0 to S7, and then here after getting the values do the round off. Okay, do the round of procedure. Then here you can get the integer values like that. What is that? Sk is nothing but 1.33 is the 1. That means use the here round off method. If that is greater than zero point 0.5, take the next value. If it is less than zero point 0.5, take the previous value. That means 1.33 gives 1, 3.08 gives 3, 4.55 gives 5, 5.67 gives 6, 6.23 is 6, 6.65 7, 6.86 7, 7, 7. Okay, in this way you can get the new SK values like this. Okay, observe this one. Okay, so now here, what is our understanding here from this? So here, RK values are 0 to 7, but our modified image or enhanced image or after applying histogram equalization transformation operation on the particular image, you can get the SK values like this. That means you have or the image is having 1, 3, 5, 6, 7 intensities instead of 0, 1, 2, 3, 4, 5, 6, 7. Okay, right? In the input image, you have all these intensity values, right? But here, for the modified image, so the intensities, the gray levels are 1, 3, 5, 6, 7. Of course, right? Now immediately we should find out the how many pixels are there with these intensities. To get this PS of SK from SK, right? So here observe the here relation. So here SK is a 1, right? So that means for input 0, you can get the SK like 1. So here how many pixels are there with the 0 is coming to the pixels for the 1 in the output image. So okay, here observe. So here our SK is 1 means, right? So here observe this one. This one is related to the input RK R0 value. Now here observe the table. For R00, what is the PR of RK? 0.19. That is nothing but here PS of SK for 1 intensity. So take 0.19. Similarly, here observe 3. This one is here related to the what is that? Input R1. So here R1 intensity is having 0.25 probability. That is nothing but here note down for 3.25. And then next intensity is 5. For 5 here coming observe here 2 is there in the input side. For 2 what is the intensity? 0.21. So take that one 0.21. Okay, for 5. And now here observe the 6. So here for 6, what is that? Two intensities are there for 6. One is the 3, another one is the 4. Right? So here for 3 intensity, PR of RK is 0.16. For 4 intensity, PR of RK is 0.08. You just combine those two. After adding these two, you can get 0.24. That is the PS of SK for SK6. Now observe the 7. 7 is related to 5, 6, 7 intensities in the input. Now observe the 5, 6, 7 intensities and take the PR of RK values 0.06, 0.03, 0.02. You just add these 3 and then here you can get 0.11. That is the PS of SK for the SK values. In this way, you should establish the table here that relates SK and PS of SK. Okay, right. So, okay, here what is the observation here? We have started here RK to PR of RK for the particular input image. But now what is the resultant one? Enhanced image. Particular here SK is 13567. PS of SK is like this. Okay. So here uh, then after applying, what is that here? Transformation operation. What is that? L minus 1 summation P or of Rj. You can get the SK. Right? So that means here you should draw the transformation characteristics in between sk and rk. So here this is the graph, right, which describes the transformation characteristics, okay, right, between sk and rk, input and output. Okay, that means here input is rk, so take the values, right, 0 1 2 3 4 5 6 7 gray levels, and then sk on y axis 0 1 2 3 4 5 6 7 values. Now here for 0 rk, right, for 0 is the intensity, what is the output here? 1. So round off, after round off, but here take the exact values, okay, 1.33. So mark here 1.33. Now here for 1, what is that? 3.08. So here staircase transformation characteristics will be appear, observe here, okay, right? So for 1 3.08, for 2 4.55, for 3 5.67, like that. So okay, right? So here draw the characteristics like this. So here this is nothing but transformation characteristics between SK and RK, right? It's okay. Now here the next one is same here. This is the original histogram and this is the transformation function. Now coming to this one. Okay, equalized histogram. How can you draw this one? Based on the SK and PS of SK values. Okay, so here is a table. Okay, right, from this mark 1 3 5 6 7 like this. 0 1 2 3 4 5 6 7 levels are there, but here we have only 1 3 5 6 7. So remaining 0 to 4 intensity levels are there, but number of pixels with that intensities 0 to 4 in the enhanced image is nothing but 0. Okay, that means there are no pixels with the 0th intensity. There are no pixels with the 2 intensity. There are no pixels with the 4 intensity. Okay, now here from this particular table, so here put all the values here, PS of SK values in the graph, right, like 1 intensity, this one, 3 intensity, this one, 5 intensity, 6 intensity, 7 intensity. So that gives the here histogram, okay, equalized histogram or enhanced image histogram. So here observe this one here. So here this one is, this nature is like this, okay, observe this one. But here observe this one. So here this uniform distribution is there. Okay, right? That means histogram is distributed uniformly instead of like this. So that means here some we are here. What is that? We have added some more pixels at the higher intensities. Am I correct? And you can neglect the some intensities. Okay, right? So you neglected some intensities, you added some intensities. Based on this, you just our image is equalized. Am I correct? Histogram is equalized. Okay, this is nothing but histogram equalization. So that means here histogram equalization means according to this equation only, we just change the, right? What is that? This PDF or histogram. Okay, right? So here in this user intention, user interest is not included. So here if you want to add some more pixels on 4 also and some more pixels on 2 also, some more pixels on 0 also. If you decide the particular resultant histogram, then you have to go to the histogram matching or histogram specification. Okay, right? So here histogram matching or specification means according to the user intention, user specifications. So you just establish one equation. According to that equation, so here you can get the equalized histogram. But here, this one, what is that? Histogram equalization method means there is some fixed formula. Using this formula, right, you just find out the equalized histogram. Okay, right. Okay, this is the difference between the histogram matching or specification and the histogram specific histogram what is that, equalization. Okay, it's okay. So here, next one, this is the problem. So homework problem. So note down, for given image of size 64 by 64 with the probability of gray levels, find histogram equalized image. Okay, so here intensity levels are given. So here this is the one it came in the paper 2019 regular. Okay, so note down this one and then do this problem as a homework. Okay, now take the another problem. Perform the histogram equalization for the 3-bit image. Image is given, so you should establish here table from this. So that means here what is the upper value here, upper intensity 5. That means here what is the here image resolution. So 5 means closer to 7. 7 means 3-bit image. In such a case, how many gray levels are there? 8 gray levels, starting from 0 to 7. Okay, you just use that one. So now 8 gray levels are there. So now note down how many 0th pixels are there. 0th intensity pixels are there. How many pixels are there with the 1 intensity? How many pixels are there with the 2? 3, 4, 5, 6, 7. Okay. So then you can get, if you observe this one, here this one is having only 3, 4, 5 intensities. You just get the value, that means non-zero value at those intensities, 3, 4, 5. So after finishing that one, what is that, RK, NK, and add the third column, PR of RK. So PR of RK means image size is image size is needed. So our total number of pixels are needed. What is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a 5 by 5 image. 25 pixels are there. So divide the each value with the 25. Then you can get the third column also. After finishing the third column, you just draw the histograms for the input image. What is that? First one NK versus RK. The second one is PR of RK versus RK. Draw the two graphs. And then later, after finishing this, apply the histogram equalization transformation operation, that is L minus 1 summation PR of RJ, cumulative addition. Okay. Now use that one and then find the SK value. SK, after getting the SK, round off the SK values and then establish SK to PS of SK. Right, and then now draw the graphs, transformation characteristic graph between the input and output SK versus RK, and also draw the equalized histogram. Okay, that means the output image histogram. So that is nothing but PS of SK versus SK. So you just draw all these diagrams and the tables. Okay, and then based on the formula do the calculation. Okay, so and then this one also homework. Okay, right? Thank you, ma.